Potential energy. Potential energy is a kind of mechanical energy. How can we define potential energy then? It is the energy due to position or configuration. Let's see some examples. Stretched rubber band, water in dam, raised objects, etc. They are having some amount of potential energy. So when you stretch a rubber band, you are doing some work on it. This work is stored as its potential energy. We know that water in dams are able to rotate turbines. So they carry some amount of potential energy. When you wind a toy car, you are doing some work and this work is stored as its potential energy. So these are some examples. Now let's see what is gravitational potential energy. Energy due to height above the ground. So here you have an example. I am going to take this object from the surface to some height h. So when the object is on the ground, there is a force acting on it, that is the force of gravity, that is mg. In order to raise this object, I have to do some work. I have to apply a force which is equivalent to the force of gravity. So the force I am applying is equivalent to what? Its weight. And because of that force, I am able to raise it through some distance h. So we know the expression for work, that is work is equal to force into displacement, and that work is stored as its potential energy. So what is the force here? It is the weight mg. What is the displacement? Yes, it is the height h. So we get work is equal to mgh, which is equal to the potential energy. This will give you the expression potential energy is equal to mgh. And what are the important points about gravitational potential energy? The first one is, does not depend on path followed. So here we have three paths, 1, 2, 3. I can take this object through any path. In any way, I am doing the same amount of work, which means it does not depend on path followed. W1 will be equal to W2 will be equal to W3. Okay. And the second point is, depends on the reference level. So we can choose our reference level. Here, my reference level is the ground level or the zero level. So an object will be having an amount of potential energy at one level and a different value of potential energy with respect to another level, because potential energy depends on initial and final points. Okay, when the object is at the ground or on the ground, it is having some amount of potential energy, but we are considering this to be the zero level, and we are taking the potential energy here and we calculate the change in potential energy. And now we are going to see law of conservation of energy. This is a very important point. What is law of conservation of energy? Energy can neither be created nor be destroyed, which means energy can only transform from one form to another. This means that total energy of an isolated system remains constant. This is valid in all situations for all kind of transformations. We will discuss this with the help of an example here. We are going to drop a ball from the height h. And you have 3 points here, A, B and C. When I am dropping this object, what is the initial velocity? It is u equal to 0. But just before reaching the ground, this ball will be attaining its maximum velocity. So here, since there is no velocity, the only energy is the potential energy. At A, the potential energy is equal to mgh. We know that the total mechanical energy is equal to potential energy plus kinetic energy. And when you consider the point B, which is an in-between point, so here we know that at point B, it is having velocity, at the same time it is at a height h from the ground. So there is potential energy and kinetic energy. And when we consider the point C, height is equal to 0, but the object has attained what? Maximum velocity. So there is kinetic energy here. So, with this example, we are going to see some important points. Total energy is equal to potential energy plus kinetic energy. At A, there is no kinetic energy, but there is potential energy. So, total energy is equal to potential energy. At B, kinetic energy is not equal to 0 because it is having some velocity. Potential energy is not equal to 0 because it is having some height. So, total energy is equal to kinetic energy plus potential energy. And at C, potential energy is equal to 0 because H is equal to 0. Kinetic energy not equal to 0 because the ball has attained maximum velocity. So, total energy is equal to kinetic energy.